from your previous day's lecture? Anything you need to know? Any comments you need to give?
Everything is fine, ma'am.
Okay. So, I think we talked about forms of data, right? Yeah. So, am I correct? Did we talk about forms of data on our previous lecture? Okay, so data can come in many forms. Uh, so, there can be matrix form, multi-relational data, time series, spatial data, string sequences, hierarchical structures. I think we talked about these things on our lecture on last week. So, so a table is a very important way to store data. It is a very simple way and a very important way, because when we store data in a table, we can we can understand the data very easily. We can make the relationships between data very easily, right? So when we store data in a table or matrix, we can also mention as a matrix. So there are data objects. So this okay. So here you can see data objects are these things. These we enter one object, one by one objects to a table, right? So when we talk about an object, the object has many attributes. If I think you have done object orientation, the concept object orientation. I hope that you have learned that concept by now. So if you haven't, you can search and see. So in an object oriented concept, we have we model everything in our world into an object, right? So in an object there are attributes and functions, so that is our object oriented concept. So here also, if we take one object, there are many attributes for that object. So all the objects in the table have the same attributes. So what are the attributes? Attributes are the column names actually. So for example here, ID, marital status, income, laptop. So these are the attributes. These are the attributes of this table, and each and every object here have those attributes in the table, right? So this kind of data, if all the objects have the same attributes, this kind of data can be represented in a table or in a matrix, right? So matrix means, for a matrix there's a size n by m. So n means number of rows, m means number of columns, right? N number of rows, one for each object, right? So one row is known as one object. One row is known as one object. M column means one for each attribute. So the column name means the attribute name. So the attribute name of that object. So here you can see there are 2 dimensions of this object in this data set, but here there are 3 dimensions. Okay, so there are 3 dimensions in this kind of representation of data. So sorry. So um, here you can see PC, book, shoe, clothes. So these are some products. So here in this multidimensional data cube, we have the relationship between the products, the quarters of the year, and the territory or the country, right? So like where the product is being produced and in which time of the year the product is being produced. That kind of information we can get through these data cubes, right? So when we collect data and when we use data for processing, we must make sure that the data has a good quality, right? Data quality plays a major role when we use data for analyzing, right? So data quality problems, there are certain data quality problems. If the data has noise and outliers, if there are missing values in the data set, if there are duplicate data, then the data quality decreases, right? So what do we mean by noise and outliers? What do we mean by noise and outliers? So can you go through these paragraphs here? I have mentioned what noise is, what outlier is. Can you quickly go through these paragraphs and somebody explain me what a noise is and what an outlier is? I'll give you a little bit of time. Quickly go through these two paragraphs about noise and outliers. Okay, so can somebody tell me what noise is, as you understood? Yes,
Unwanted data?
exactly. Unwanted data. So there can be data in a data set. There can be data that we need for our processing, that the data that are actually valuable for our processing stuff, and there can also be some other data, but that data is not usable for our analysis or our processing stuff. Okay, so that is unwanted. We do not want that data. So for example, so normally what we mention as noise is very familiar for us through sound, right? So when we are when we are listening to a music, if at any point some other sound that we do not want to listen, or some other sound that is not there in the music is being heard, then we say that there is a noise, right? So same goes to when we are working with data. So if we are working with some set of data, and if there is some other set of data that we do not want, then we mention that is a noise data, right? Undesired variations. So for example, a bulk of messages in a news group that do not add anything to the discussion, right? If you are so this also normally happens when you are in a news group, or if you are chatting, if you are talking in a group, you have a topic, right? That group normally has a topic, but if you are talking about something else which is not related to that topic, then that something else data, those text messages or those other media that you share will be noise, right? So distortion of a person's voice when talking on a poor phone, so that is noise regarding uh, hearing, right? So anything that we do not want is known as noise. So if there are noise in a set of data, if there are a lot of noise in a set of data, then that data quality decreases, right? Because if there are too much noise in a set of data, then it means that that data set is not accurate. A lot of data which is there is unwanted, so the quality of the data set will be decreased. So what about outliers? What did you understand by outliers?
Errors?
Um, we cannot say that it is an error actually. It is something related to abnormality, right? It is abnormal, or a data which is not normal, a data which has some characteristics which are not similar to the characteristics of other data set, right? uh, for example, uh, credit card fraud detection, right? So this characteristic called outlier is being used in the real world for detecting credit card fraud, right? So for example, let's say like this: you have a credit card, you normally pay for certain shopping stuff using this credit card. Okay, so normally you have a payment range, right? So you normally per month you pay for stuff around 20,000, 30,000, like that, right? So if in some day uh, you either you or some other person who has stolen your credit card, he directly tries to pay some amount more than, like, let's say 2 lakh, right? So normally you used to pay amounts around 20, 30 or 50,000, like that. But if there is a payment being done suddenly, a payment around 2 lakhs, which is very abnormal to the daily payment that you have been doing. So that is an outlier. So that payment value is an outlier. So whenever such large amount of data is being asked to pay, so that when that amount of data is being asked to pay, then the system will detect that that data is an outlier, or that payment is an outlier, it is not normal. So it will inform either you or some any other security system which is available, right? So outlier means data which is different from the other data in the data set, right? From most the other data in the data set. So these outliers are normally used for credit card fraud detection or defect detection in manufacturing process. So when some products are being manufactured, there are certain characteristics for those products, right? So if there is a product which has different characteristics, then that product will be detected. Maybe that is a defect product, right? Maybe that is a different product. So it will be detected by checking for outliers. Okay, so same goes with data. So if there are a lot of outliers, or if there are outliers in a data set, we normally do not use those outliers, right? We normally do not use those outlier data, because it will affect our processing or our analysis in our data set, right? So how do we handle noise and outliers? So we have a process called data cleaning, right? Data cleaning. So we can directly remove our unwanted data or the outliers, right? If there are some unwanted data in our data set, we can directly remove those data. If there are outliers in our data set, we can directly remove those outlier data, and then we can do the processing with our accurate data which is remained, right? So however, there are certain there are some sometimes you have to consider about outliers, because outliers sometimes might not be actually an abnormal data as well, right? Outliers might not be abnormal data as we think, right? So for example, there is something some right, some situation. So when you go downwards in the ocean, right? So this is the surface of the ocean. So when you go downwards, the temperature changes, right? You know that when you are going downwards in the sea, the temperature change. So normally the temperature is a little bit high on the top because of the sun rays and stuff, and when you go downwards the temperature will be low because there are low light coming to the ocean, like that ocean bed, right? However, the temperature normally, if we draw the temperature and the depth of the sea, we can get some, we think that we can get something like this, right? The temperature decreases when the depth of the sea increase, right? So this is the depth of the sea, right? This is the temperature here in this side. So the y-axis represents the temperature and the x-axis represents the depth of the sea. So when the depth of the sea is increasing, the temperature will decrease. So this is normally what we think. However, it is not actually like that, right? It is not actually like that. So studies have shown that the temperature will gradually decrease for some moment, and it is something like this: the temperature will gradually decrease for some moment, and at some sorry about my drawing. So if I start from here, if the temperature decreases for some time, for some depth, and suddenly it increases, right? Suddenly it increases. So there is a situation like that. It suddenly increases and then again start to decrease when you go downwards, right? So that is one, that is a phenomena. So if we take this temperature here as an outlier, the temperature here as an outlier, and remove it, then we won't be able to understand that that there is a phenomena where the temperature suddenly increase when you go downwards in the ocean, right? So that is a situation where you have to carefully consider about the outliers, right? You have to carefully consider about outliers. So there are situations like that also. So just because some abnormal data is there, you cannot directly say that this is an outlier, this is a noise, and remove it, right? So there is another way the data quality will decrease is missing data, right? Missing data. So normally, why do data is missed? Is one is so normally when we record data by collecting information, right? We can collect information or data through questionnaires, or we can measure some data. So normally geological or geographical data we measure. So human, if we want to collect some human related data, then we can ask from people. We can build a questionnaire and give them to fill, right? So people might fill all the questions, people might answer all the questions, or people might not answer some questions. If they feel uncomfortable for answering certain questions, they won't answer. So we do not have that data. When we collect the answers, we cannot, we won't be having some a part of the answers because the people did not answer it, right? People decline to give their age and weight, for example, right? Some people might not like to reveal their age and weight, so they won't put that information in the form, right? So that information won't be collected. sometimes some attributes may not be applicable to all cases. For example, the driving license is not applicable to children. So if in a form, or if in a questionnaire, if the driving license number is required, then children who are, if the questionnaire has to be answered by children as well, the children won't be able to answer that question, right? So that data won't be collected also. So like that, some part of data or some data might go missing. So when we are handling missing values, there are several ways that we can handle missing values, right? We have to handle these data problems before doing our analysis, right? So how do we handle missing values? We can eliminate data objects. So if there are missing values in a row, we can directly delete that row. So for example, if we see here, so if we see here, you can see all the rows, all the cells are being filled. So let's say if there are some data which is missing, so the income value of the third row is missing. Then what do we do to handle that missing value? We eliminate the whole row. We delete the whole third row here, right? So that is one way to handle missing values. Or we can estimate a value. Okay? We can estimate a value. So for example, when we are working with geographical data like temperature, pressure, those kind of data. So if there is a missing value, let's say for temperature, the temperature has not been recorded at that particular point, but there are temperature values recorded nearby. So what do? Is we take an average value. So the temperature value nearby, right, or around the data point that we have measured, if that information is available, then we can use an average value. So that is an estimate, right? So we estimate the missing values. And the other way to handle missing values is we can ignore the missing values. When we are doing analysis, if there is no value for some attribute, then we can just ignore it. It doesn't matter. We have the other values. We can use the other values for our analysis, right? So missing data can be handled like that. So then there's another way where data quality will be decreased is if we have duplicate data, right? If the same data is recorded again and again, then we call that a duplicate data. So data objects that are the same or almost the same, right? So for example, this situation happens when we merge data, when we start to merge data. So for example, let's say one of you collect personal data of maybe children, right? So the children's name, her address, her contact details, all of them are collected. Then another person collects the hobbies of those children. Then again the children's names, the age maybe, then the hobbies, those information will be collected. The address, contact details, all of them will be collected. Then another person similarly collects some other set of data from the same category or the same children. Then you meet with your supervisor, or you go to analyze that data, then there are three sets of data because three of you have collected. Then you have to merge those data. So at this moment, when you are merging, sometimes you might add the same data again and again. Maybe it's a mistake, maybe it should be added, right? We do not have a choice. So like that, data can be duplicated. So especially when these data are merged with each other using a software or using an application software, then normally data gets duplicated, right? So if the same person with multiple addresses, different insurance policies or different contact details, so like that, if there is some person like that, the person's name and other details will be duplicated. So you can handle duplicate data. One is data cleaning. What is data cleaning? Here you can see removing the data objects. So if there are duplicate data, we can remove one set of data, right? Or you can record the data, complex name records, right? You can leave that duplicate data, but you have to label those data, right? So like that you can handle duplicate data. Okay, so can you do these activities? So here I think you can remember on the last week also what we did was we scanned this QR code and we gave some answers. So here also what you have to do is you can scan the QR code and a question will be appeared. So actually the question is, which data collection methods are you familiar with? So the data collection methods that you are familiar with, can you enter them? I think you can give several answers. So please provide answers to this question. What data collection methods are you familiar with? How do you collect the data? Right? Can you do it now? Okay, so these are some data collection methods that you and some people have added. So see if there are any familiar ways that you can collect data. So normally to collect data, we can do interviews, right? We can interview people, right? We can interview people. We can provide questionnaires, right? As I have mentioned previously, we can provide a set of questionnaires for some group of people that we are focusing, and we can ask those people to give answers. So based on the answers, we can do our analysis. So we can build our data set. So so that is questionnaires. That is the most common one. And interviews also, it is a very common way to collect data. We can like meet some people, a group of people that we are focusing, and then we can ask questions, or we can discuss with them, and based on their answers or based on their ideas, we can collect data. We can also collect data through documents and records, right? We can read those records and documents, and we can add those data into a table, or maybe we can create a matrix or things like that, right? We can use polling means chande, we can use polls. We can ask people to vote for a certain like we can create a topic, and we can ask people to vote to which way that they agree to, like that. So in a country, what happens is there are political parties, and people are asked to vote to the party that they like, maybe the party or maybe the person that they like. So what we are doing there is we are collecting data, we are collecting the desire of the people, right? So how much to which person does the people like, things like that. Okay, so we can do surveys, right? We can search, or we can read. So it is pretty similar to the documents and records, right? We can we can create case studies, right? It is like we can create a case study, and we can give that case study to people, and get their ideas about that particular case, right? Like that. We can use group chats, or any other online messaging systems, right? Web-based questionnaires, social behavior. We can use social media to collect data through how people interact with social media, right? So through things like that, we can we can collect data, right? We can collect data. So those are some of the data collection methods available, right? So yeah, there are two methods: primary data collection method and secondary data collection method. In primary data collection method, what happens is, you can see here statistical methods, surveys, polls, interviews, Delphi technique, focus group, those are primary data collection methods. So what happens here is we directly deal with the person who is providing the data, right? We ask the person, we give him some chances or some categories and ask him to choose one or several, right? We can do mathematical implementation. So here we directly work with data, or we directly work with the person who is providing the data. So secondary data collection means things like financial reports, sales reports, government reports, mission, vision statement, internet. So here what we do is we do not directly work with the person who is providing this data, right? We do not know who wrote the financial report, but we read the financial report and we want to take what is suitable for us or what is uh, valuable for us through that report, right? So we have to search for data here. We have to search for data. So in a financial report, we have to search for the particular data that we want, right? In a government report, we have to search for the particular data that we want. In vision mission statement, also we should read them. We should read them and we should understand what data or what is the thing that is being mentioned, things like that. So those are the secondary data collection methods. We do not directly have black and white data here, right? So why do we need to collect data? So can you go through this slide? Can you go through this slide and get an idea? Okay, so why do we collect data? Can somebody explain?
Decisions can be made by collecting data.
So that is one. Can any other person explain? Why do we need data collection?
Gain customer feedback.
Yeah, we can collect customer feedback. So why? I mean, yeah, we collect customer feedback. Why do we collect that?
We discuss obtaining customer feedback on products above, but products feedback isn't only valuable. Inside you, we can gain.
So we can like collect the customer data or customer feedback, and we can use that feedback to see whether we are walking in the right path, or whether whether our products are being liked by the customer, right? So you can learn about your customers. What do they like? What are their desires, right? You can discover trends, how people change their opinions and behavior over time or in different circumstances, right? So there are certain some incidents might happen when we live in a country. So based on those incidents, maybe racial or racist some incidents, so people will like some products, and people will what is it? The people will avoid some products. So like that. So the trends might change. The trends will change. So you can also segment your audience. You can divide your audience, or you can divide your customers into different groups, and you can use different marketing strategies for those groups, right? For example, when you are like selling some products, you can produce those products in different qualities, right? So the best quality products will be bought by customers, maybe your loyal customers, maybe the customers who are affordable. But a little bit decreased quality products will be bought by customers who cannot afford a very large amount of money. So like that, you can group your customers, and you can provide the products according to those groups. So that is what happens in the world actually. So the countries which we call developed countries, they use the best quality products in any product, which is being produced internationally. They use the best quality products, and countries like our country, or the still developing country, or we say the third world countries, so those countries get somewhat low quality product. So those low quality product will be cheap and will be affordable by those countries, right? So that is what happens throughout the world. So like that. So information or data about customers or people who buy the products will be used to build different segments of your customers, and you can make decisions, right? You can make decisions by using the data, right? So historical data, or the data from the past few years, can be used to make certain decisions about the future of the business, or the yeah, of your uh, business, right? So it helps resolve issues. If you get any issues, and you can also improve the quality of your products or services based on the feedback obtained. So that is like customer using customer feedback to improve the quality of your products or services. So when we talk about data, there are two types of data, quantitative and qualitative data. So quantitative data, it has a quantity, right? It has a quantity. We can like count the amount of this data, right? So deals with things that are measurable. We can measure, and we can it can be expressed in numbers or figures or other values, right? We can express the quantity of that data. So for example, size, length, duration, amount, price. So here all of this data we can provide a quantity. So size can be small, size can be 24, 26, like that, or maybe small, medium, large. If you talk about length, we can mention here also the amount, right? The we can numerically express the size of or the values of these data, right? So normally quantitative data can be collected by asking these kind of questions. Who? So when a question like who is asked, then a name or a certain person can be mentioned, right? Or a certain value can be mentioned. When, where, what, how many. So all of these questions can be used to can be used to get quantitative data. And there is another data type called qualitative data. So in the word itself, you can see quality. The data is the data mentions about the quality of the data. So it is descriptive rather than numerical. We cannot sometimes say the quality is 100 like that, right? It is rather than expressing it in a numerical way, we can express in a descriptive way. So measuring qualitative data is not as easy as measuring quantitative, right? So people's thoughts, people's desires, so those things can be measured using qualitative data, right? So what we do is we observe, or we give open-ended survey or interview questions to collect qualitative data, right? So normally we use questions like why and how to collect qualitative data. So thoughts, feelings, right? If the person likes something, if the person does not like something, those kind of data is known as qualitative data, right? So quantitative data collection can be collected using closed-ended surveys. So closed-ended means, what is closed-ended? So here there is a certain answer, right? There is a certain answer. So for example, you can see a question here: which one of the Christmas specials do you like the most? So if you haven't tried them, which one looks the tastiest? So this is an advertisement from a shop actually. So here the answers are being provided, or the categories of the answers are being provided. You have to select from one of these, right? You have to select one of these answers. You have to select from this one from these four, one or several. So the certain answer is available here. So that is closed-ended surveys, online quizzes, like that. So open-ended surveys means Open-ended means the answers have not been provided to you, right? So for example, like here, so this is a closed-ended question. In a closed-ended question, you can see, why don't you eat ice cream at fictional's ice cream parlor? Choose at least one answer. So here the options are provided to you. So maybe you do not like the flavors, maybe the ice cream is too expensive or the service is bad, things like that, right? So the options are given to you. So you have to choose from one of these options. So that is closed-ended question. If the question is an open-ended question, then if you see the same question, you can see the same question here, but the answer that you provide will be different. The categories of the answers are not given here. You have your freedom to write anything or give any answer to this question, right? So that is an open-ended question. So data collection can be done using one-on-one interviews, focus group, direct observation, like that, right? So actually open-ended question is easy to collect. The person can write his own views, but when we are converting that data into a storage, like if we are using an Excel sheet to store data, then in this situation, actually in this case, we can simply use these answers and we can count how many people answered this question, these answers, or how many people gave this kind of answer. Like that we can count and numerically count, right? But in open-ended question, we do not count, or we cannot like measure directly. So we have to read this whole paragraph and we have to convert it into some way to store, right? So it is open-ended questions are a little bit tricky than closed-ended ones. So after we collect data, we have to use that data for analysis, but before that we have to prepare that data, right? We have to prepare that data. So from here onwards, here we have collected the data and then we have to prepare the data. So this is a process of cleaning and transforming raw data prior to processing and analysis. So we have to clean the data here, right? Data cleaning. So data cleaning means you can avoid or you can remove the reasons for having a low quality data, right? So the data quality can be, in order to increase the quality of the data, you have to clean the data, right? So here what we do is we transform the raw data prior to processing and analysis. It is an important step prior to processing and often involves reformatting data. So we can reformat the data, making corrections to the data and combining data sets to enrich the data. So what do we finally do here is we enrich the data, we increase the quality of the data. So why do we do that? When we have a high quality data, it is very efficient for our analysis, right? The results will be correct 99%, or the results will be accurate if we have good data. So it is efficient for analysis. Preparing data is efficient for analysis. Limits errors and inaccuracies that can occur to data during processing. So less errors can be happened when the data is correctly prepared, right? When the data is correctly prepared, less errors or less inaccuracies will happen, right? Makes all processed data more accessible to users. So when we prepare data, sometimes users will be able to understand what kind of data is there. Unlike in the previous stage where the data is only collected. So after we prepare the data, anybody or most of the people who view the data will be able to understand or will be able to access that data, right? So data preparation, what happens is we gather the data, we discover, cleanse, transform, enrich, and finally we store the data. So this is what happens during data preparation, right? During data preparation, we gather data, discover, cleanse, transform, enrich, and store, right? So you can read about this, how data is being gathered, how we discover and assess data, how we cleanse and validate data, right? So this kind of information, this kind of things you can read from this slide. I have included some description about it, right? How we can prepare data for our analysis. Right. So let's see if so this video here, it shows about how we can achieve perfect data. So we can how we can gather or how we can collect and make perfect data prior to analyzing. Okay. Okay, so yeah, there's a small video here. You can see how to achieve perfect and compliant data.
Hello, my name is Ashley. I'm head of marketing for Acme Fashion, a rapidly growing footwear, apparel, and fashion company. We found ourselves facing a new challenge, a company mandate to increase customer centricity. And this year, we want to significantly grow our Black Friday and Cyber Monday sales. We plan on rolling out a personalized campaign where customers will be guided to the products that fit their size, typical budget, and meet their preferences and buying intentions. Our goal is to increase sales by $3 million. And today, being November 14th, we have at least 2 weeks maximum to roll this out.
Wait, you mean you need this next week?
Sorry, yes. Mark is our director of IT at Acme Fashion.
And no magician. The last time we did this, remember we had this back and forth ping pong and I had to develop the processes to your requirements? And I think it took about 8 weeks.
True.
And this time we have a new European regulation to consider, the Global Data Protection Regulation, GDPR.
Which mandates us for explicit consent from our European customers when we deal with their personal data for one-to-one interactions.
Right. And I don't even have this opt-in data in my system. You outsourced this data to a third party with your marketing automation system, and I was not even in the loop for this outsourcing decision. Now, there's no way to achieve compliance without this opt-in data.
I understand this deadline might seem impossible, but now we are organized as a team, the ultimate data driven task force. Our data scientist has already designed the recommendation model for personalized interactions.
Using Talon machine learning with our big data lake to collect and prepare the data to feed the Spark-based recommendation engine in machine learning libraries. With my help, the model has been operationalized and is ready to run in the website and the mobile apps for real-time recommendations.
Regarding privacy and the GDPR regulation, our newly hired data protection officer has given me the guidelines to ensure this campaign applies only for customers that gave their consent. Together, we've found out that we just need to add the opt-in data in our data lake.
So you're already using data prep for analytics, but you're also going to use it for onboarding the data too.
I asked my marketing agency for this data, which they sent to me as a file.
Ah, okay. So you already have the data.
Yes, but I'm afraid it doesn't appear as it should in our CRM.
And you're using data preparation. Isn't this just a tool for analytics?
It's so much more. Let me show you. I've already logged into data prep. I'm going to use a new preparation using the file from my partner, which is already available here. In this case, I only really want to cleanse and standardize my opt-in customer data within the dataset, so I can choose to only view data entries labeled yes. One of the coolest things about data prep is that it's actually smart enough to understand my data. It's automatically detected that the third column is a first name, the fourth a last name, the fifth an email, and the sixth a city. This is called the semantic type, and I can adjust the data type for these columns if I need to. I can edit how the column reads my data. For instance, this is actually US data. So let's adjust the postal code for US. The real magic is indicated by this colored bar above each column. Data prep can illuminate correct, empty, and invalid values as well. When I drill down on my invalid data, I can see this email is flagged in orange. It looks like the @ symbol is missing, so I'll correct it. Data prep highlights other quality issues such as spaces in the first and last names, which I'll get rid of. I'll format the phone number with the phone standardization and make them all US national. If I drill into the state code column, I see that there are records that are DC, but that is fine, so I'll leave those too. It looks pretty good, but to fully connect this contact data with my sales organizations, I need to retrieve the sales org data related to each contact location. This is called a lookup. And now I'm done.
That was incredibly fast. And I love how user-friendly this whole interface is.
Absolutely. This panel listing my actions against the data is called a preparation. It took me no more than 7 actions, and my data is ready for you. Now, I can't just send this in an email to you as an attachment.
Our data protection officer kindly asked us to avoid replicating our customers' personal data on Excel files.
Got it. Then what I'll do is I'll simply share my preparation with you within a shared folder. I'll select the IT folder where my compliance officer has already listed you as having access. And there, now you should be able to access my file.
Awesome. I'll now show you how you can reconcile your cleansed data in the data lake with our customer data hub. I'll be using Talon Studio.
Oh, geez. I'm not great with all your techie stuff, Mark.
Don't be afraid. You'll never use this, but it's our favorite tool within IT, and it's pretty powerful. It runs natively in our data lake through Spark, so I can run any data, no matter its structure or volume. Now, last time, it took us 8 weeks to complete this whole process. I had to interview you, formalize your requirements, and get your validation. Then I needed to implement them, and then ask for data samples for my test. And then we would probably have to go back and forth to adjust the rules.
There has got to be a more efficient way to go about this whole thing.
Well, now there is. Using the studio, I can get your data and connect it with our customer data hub. I'll use a matching component together with the contact and profile data from our CRM system and with Twitter and other social profile data for deep personalization through the Twitter profile.
And using my preparation, which I personally designed and tested, I've already eliminated 15% of the supplier's junk data since it didn't match my business rules.
If I had to do this on my side, it would have taken weeks. I have brought the data into this tool for your intervention, so I need to use a T-Data Stewardship output component. The stewardship application is for your team to help me resolve records that are not matched automatically and through the matching rules. This is another great example of how IT and business can better work together.
Now I need to log into the Talend Data Stewardship application, a tool allowing business users to verify the duplicate records and compliance to validate it, since we know the data best. Here I can see your request for my review of your discrepancies.
This application looks a lot like data preparation.
Nice, right? I can drill down to the tasks assigned to me. Thanks to the semantic analysis, I know this email selected is not correct. This is the obvious correct choice, so I'll let the system know and then lock that record. The next record shows 2 different phone numbers listed for this one contact. I trust the CRM data more than the opt-in data, so I'll ask Data Stewardship to use the most trusted number for this record. I'll continue in this fashion throughout all of my assigned tasks. We'll validate my selections once 100% of the tasks are completed. Now the tasks and data go to the compliance officer to review our actions to ensure we're not overriding anything key.
Why does compliance need to review?
Just as a second pair of eyes to ensure my intentions were correct. It's always good to have someone safeguard the data lake against invalid data, since it exchanges so many hands.
Smart.
Let me introduce my compliance manager, Janelle.
Hello.
Can you show us how the whole process comes to a close at your end?
Of course. I've logged into the Stewardship app and I've got a few extra features as an administrator. And I can see Ashley's request to resolve tasks. I'll review each record, and if I disagree with any of Ashley's intentions, I'll reject the record. That sends it back to her to be corrected. Otherwise, I can accept each record individually or all records at once and officially validate the choices.
Now, all of these records can go back out to the data lake.
Yes, using another data integration job to feed it into your recommendation engine, which is queued up for the next best recommendation the product offers.
We have just completed the entire process in a handful of minutes.
Incredible.
Do you think we could meet our deadline of next week?
Thanks to Talend Data Preparation, Talend Studio, and Talend Data Stewardship? Absolutely.
Okay, so this actually promoted some application, but if you can, if you saw that video, in that video, what they did was they had a set of data and they prepared that set of data and they use some other techniques to present and finally use that data in a valuable way, right? So for that they have used certain applications. So like that there are ways or applications where you can use them to manage your data, right? So for example here, when you record data or when you collect data, there are multiple values that are commonly used to represent the same object or same thing. So for example, in for a state like California, some people might record California as CA, or some people as CAL, or some people as CAL dot, or simply California. So a data preparation tool is needed actually to merge these kind of data. So the same data can be merged, right? So so for example, in the case of US states, a unique count greater than 50 would raise a flag. So there are only 50 states in the US. So in that, when we are inputting states, when we are recording states, so if different states, if values more than 50 different states are input, then an error or a flag can be raised, right, by the application, by the data preparation tool, right. So like that, there are certain ways to prepare data. So data mining, I think we talked about data mining as well briefly in a previous lecture. Okay, so in data mining, what we do is we always want to achieve a business goal. So in order to achieve that business goal, we can simply identify the data that we have. We can prepare the data, we model the data, and we evaluate the data, and we finally present the data to the people who make the decisions, basically the management people, right? So identifying, preparing, modeling, and presenting the data is a collection of data mining, right? So in data mining, there are certain ways to prepare and manage the data, right? So classification, prediction, association rules, predictive analysis, clustering, data reduction, data visualization. Those are the things that those are the strategies that can be used to manage data, to mine data, right? So we categorize data in a basic form of analysis. For example, purchase or non-purchase products. So that is classifying. We classify the data into certain categories. Prediction means we try to predict or try to understand about something which can happen in the future. How much amount we should purchase in order to build our products, things like that. Association rules means what goes with what. So when we are selling something, you have seen sometimes when you buy something, you get something else, maybe free or maybe for a discounted value. So what goes with what? It can attract customers. Even the shelves which are stored in a supermarket, so normally the same kind of or similar or the related products are stored nearby, right? Predictive analysis means it is a combination with a combination of classification, prediction, and affinity analysis. So we can use historical data which is there from maybe from the beginning of the company. We can use machine learning, we can use AI to predict what can happen in the future. Will the business increase or decrease or things like that. Clustering means assigning data into clusters. So the difference between classification and clustering is in classification we know the categories that we are classifying the data, purchase or non-purchase. But in clustering we do not know into which categories we are dividing the data. So based on the data itself, we can build clusters. So the same data, the similarly related data can be gathered and we can build one cluster like that. Okay, so data reduction means if we have very complex data, we can convert that complex data into simpler data. Data visualization finally is we have a set of data, we prepare the data, we analyze the data, and then we want to present that data or we want to visually view that data. So when we visually view something, we can understand it more than just reading the text, right? So we use the information in a graphical way, and we analyze it graphically, right? So this is what happens normally. We have historical data and we have predictive algorithms, right? We have predictive algorithms that which are already developed by people, or algorithms which can be newly developed, and we use these algorithms to build a model, right? So by historical data we build a model, and this model can be used to do predictions using new data. So we use the historical data and we build a model. The model is static, and when we collect new data, we input this new data into the model, and then we can get predictions, right? We can get predictions. So that is how things are happening in businesses. Then there are two other categories known as supervised and unsupervised learning. So supervised learning is training data includes both the input and the desired results. So in classification, as I mentioned, we know what data we are inputting and we know what are the results, what are the desired results, what are the classifiers which will outcome, right? So for example, the correct results are known and given in input to the model during the learning process. But in unsupervised learning, we do not know what will be the outcome, right? There is no outcome variable to predict or classify. Can be used to cluster and input data in classes on the basis of their statically properties only. So in unsupervised learning, we do not know what will be the results. We do not know how many groups we will be able to classify something, right? So clustering, building clusters will happen when we are learning the data itself, right? Okay, so you are having a small activity here. I need you all to talk about the impact of information systems to change the management of an organization. Okay, organizations and management changes with incorporation of information systems. So organizations and management of an organization was there from the previous days, even before we use these software related applications and information systems. But what I want you to talk about is how information systems, right? Information systems, systems which use information and output some results, right? How these kind of systems have changed the management of organizations. Did you get the question? Did you understand the question? The impact of information systems to change management of organization. Right? I'll give you a little bit of time. You can do your research, or you can do your a little bit of searching, and we will have around you can get your break as well. You can get your break. So this is 2:50. The time is 2:50. So we'll come at 3:30, right? You can have your break, and I need you all to uh, build your ideas about this activity, right? I need you all to discuss about the impact of information systems to change management of organizations, right? So we will start our discussion at 3:30, right? So you can have your break and you can search about, maybe search, or maybe you can build your um, information regarding this topic. Okay, are you clear? Any questions
Okay.
that you need to
Okay.
clarify?
Yeah.
Okay then we'll start at 3:30. You can work on this. Uh, okay, so did any of you finalize about how impact of information systems change management of organizations? Can we start our discussion?
Okay.
Okay, then Pubudu, can you give your views?
I made Word document.
So, do you like to share it?
Okay.
Are you able to share your screen? Can you share the screen? Okay. Hello.
Okay, Miss. It's loading. Can you see my whiteboard?
Yeah, we can see your whiteboard. Give me a sec.
Miss, can you give me email address? I'm today I'm coming to online my phone. That's why I think that's reason I can't share it.
Okay, so you can talk about it. Actually, I needed not to see the document. I wanted you to talk about it. So what you have written, you can explain to us.
Okay. From an economic point of view, information system technology can be seen as a factor of production that can be freely substitute for capital and labor as information system technology automate the production process. Less capital and labor are required. The produce specified output. The engagement of staff visioning a process that encourages their participation in understanding of and contribution of future goals. The creation internal change agent group who facilitate and communication process between staff and management. The encouragement of the development of more participative leadership participating traditionally hierarchical and structural organization. A management of organizational change approach, a participative leadership and system thinking like that.
Okay, so can you like briefly tell what you have your idea about it? Just briefly.
A more systemic engagement oriented and process focused approach to the management and organizational change, unable to collaboration between leaders, managers and staff in the implementation and technology and business process changes. In order and achieve this collaboration for these points, participating leadership, system thinking like that. Empowerment.
Okay, so what are the can you tell us what kind of change happened in the management of organizations? What kind of change has happened because of information systems in a business or in an organization?
Empowerment, it's define the term of developing the organizational conditions that supporting high staff involvement and changes intelligence and sharing appropriate discussing making responsibilities among the management supervisors and staff and managing power as appropriate as the application of empowerment and like that.
Yeah, so what you're saying is, I mean, all the staff in the organization is they are linked due to the information system, and is that so?
Yes.
Okay, so yeah, so did other people understand what he mentioned? Yes. Who else are here? Gishanti, right?
Yes, ma'am. Systems are automated now, so less manpower is used and threatened to the employees.
Yeah, less manpower is used.
It's
And
current employees, it can be a threat to the current employees in the organization, and they have to adapt to the new environment.
Yeah. So, so are you telling it as a positive or a negative thing?
It depends, no? That we can't say it exactly. It should be positive, no? That is why we are going to have information system. So it.
Yeah, actually, the thing is, introducing information systems is we do introduce this information system for a positive manner, because things will be more easier to be done, and all of the people and all of the all branches of a business, all of things will be linked with each other, and a centralized database will be there. So things like that are available, and tools and applications are also available there. But the thing is, when introducing anything, first of all, I mean, in the first level, there will be some tough things, like you have mentioned. People will be needed to adjust to the new situation. Things like that can occur, but those things can be overcome uh, with time, right? So maybe the cost of new tools and applications will be there when introducing information systems, when starting to use information systems. Things like that will happen, but with time, the advantages will approach, right? So I think it is that kind of idea. Can we have who is this? Dishan. Dishan's idea also. Can we get it? Dishan, are you there? Dishan Shanuka. Shanuka. Can we have your idea? Okay, give me a sec. Okay. So, so that will be all about business analytics and stuff. So next we will be talking, we will gradually move on to geographic information systems, right? So I think I have mentioned on last week also, you will be doing, you will be yeah, you will be doing your assignments and your practical stuff in using GIS. So GIS related applications will be used. Okay, so we will start talking about GIS, what GIS is, what is geography, and what are information systems, right? So what is geography? When we talk about what geography is, it is, I think you all know that geography is something to do with the earth, right? Anything to do with the earth itself. So here we study about the earth, uh, our surroundings and stuff. We can study about lands, features, inhabitants, right? Phenomena of the earth, not only about the land. Uh, when we mention about geography, we normally the thing that comes into our mind is about the study about the land, right? But not only land and the sea and stuff, but also about the people who live, right? The inhabitants, the societies, religions, races, right? Anything, okay? Phenomena, things that happen on the earth, things that happen above the earth, anything which happens in the spatial area or in the space uh, on the earth, we refer to as geography. Okay, so that is geography. And when it comes to information systems, what do we do in information systems? We normally, the basic things that we do is we collect data, as we have talked about in our previous lecture slide. We collect data, we organize data, we store data, and then we communicate about that data and information with each other. So information system is a system for collection, organization, storage, and communication of information, right? So what is GIS? So GIS is the combination of these two fields, geography and information systems. The study about the earth and its surroundings, and storing and doing all that information related stuff is called GIS, Geographic Information Systems, right? So computer systems and programs, they help to answer questions about the world, right? So from the beginning of the human race, human beings have always been curious about what is happening around us, and they ask questions, right? So according to the technology which was available in those times, people tried to find answers. So in the earliest days, there were certain, they didn't have any technology like computer systems and stuff, but they had their imagination and they had their curiosity. They used certain tools to find answers to the questions that came. So time by time, gradually when the technology developed and it increased, and with the introduction with the computers and other electronic devices, people started to find answers find deeper answers and deeper solutions for the questions which arouse, right? So in this GIS field, we use computer systems and programs, computer applications, in order to help answer questions about the world, right? So what are the questions about the world actually? Normally what we ask about the world is where it is, where is it, right? Where is it? What else is nearby? Where can I find things with a certain characteristic? Where is the closest something to my location, right? So normally what do? We normally turn on the Google map and we type something, some place, to check where that place is located, right? And if we are going on a trip, say we are going to explore historical places in Sri Lanka, so we go to one place, maybe Anuradhapura, in one at one location. We stop and we check what else is nearby. What are the other historical places which are there situated nearby? Or where can I find some? Where can I find things with certain characteristics? Right? Maybe restaurants, right? For example, you go to a certain place, and then you want to like search for a restaurant, or you want to search for a place to have a cup of tea. So you turn on your Google map and you just type maybe restaurants, maybe certain keywords you type, and you see where they are located, right? So what is the closest shop, or what is the closest hotel to my location, right? Like that. So all of these things are situated on the earth. Some of them are man-made, some of them are natural. However, you can search, you can explore, right? You can find information about these things. So those are some sample questions about the world that you normally ask, right? So in GIS, as I mentioned before, in GIS we try to find the answers to questions about the earth. Certain applications have been developed in order to provide answers. So Google Map is one application. The Google have developed an application in order to for people to find information about the earth basically in real time, right? So GIS try to model things on the earth. So the whole earth is created as a model, right? The whole earth, every place on the earth you can access through your mobile phone, right? I'm talking about the application Google Earth itself. So everything on the earth, every location and stuff is accessible, or it is modeled in a way where you can access them through your mobile phone, right? So that is the combination of geography and information systems. One application where the combination of geography and information systems is available, right? So GIS try to model things on the earth. In GIS we use a process to build these models. We use a process to build these models. You can see here there are certain activities being done, certain levels, right? So basically we collect data, raw data. We can collect that data using maybe satellites, maybe other remote sensing techniques, right? We collect data and then we store that data, or we convert that data for information and we store it. Then we use this information to analyze. We apply certain algorithms, we apply certain strategies, certain techniques to analyze this information or analyze the raw data itself. So after analyzing, we visualize that data. So the most important part here in GIS is we can visualize the data. We can visualize the data and information. So we can like build an understanding about the situation, the current situation, right? So visualize this data. For visualizing this data, we use maps, basically maps. In GIS, the most important visualization method is a map. So maps can be 2D, 3D or any other dimension. However, we use maps to visualize what we have analyzed, the relationships, the patterns and everything we use to visualize. And according to this visualization, we build plans, right? According to the visualization, we build plans. So by just looking at the basic information, we are not able to understand the current situation. We are not able to understand what is happening or how the layout is, right? But after visualizing these things, we are able to build a plan. So it is easy for us to build a plan. According to this plan, we can make decisions, right? We can make decisions, and we can work out these decisions to various kinds of things. So after we make a decision or after we complete this process, we build a map, right? We build a map here. So this map contains all the information which has come from this level, this point, and which has gone throughout all of these levels, right? This map has all the information which has gone throughout this circle, right? So that is how the current world map is there. So in the current world map, we can, so if you take the atlas map, we can view the forests, the lakes, the rivers, the mountains, everything is there, right? And this map should be updated time by time because people are changing the world. People are cutting down forests, they are cutting down trees, so the rivers will be drowned, rivers will be dried, and certain phenomena also happen, things like tsunami and stuff. So because of those things also, certain islands will be disappeared, things like that has happened. So these maps also are updated time by time with the collection of data. So this is a never-ending process. This is a circle, right? A cycle. So all of these things are happening again and again, right? So the objective of the GIS is actually to improve overall decision making, right? Objective of GIS is to improve overall decision making. We are able to make decisions based on GIS, right? So GIS software are available. I think I have mentioned we are supposed to do this QGIS software. So free GIS software are available. Some you have to pay some amount, some are totally free. So QGIS is a totally freely available software. ArcGIS, in ArcGIS you have to do some payment for certain features like that. Okay. So things we can do with GIS. we can make maps. Basically, we can make maps, right? So we can also make maps and charts. So different maps, different types of maps, transportation maps, atlas maps, aeronautical maps, navigation chart. So these kind of maps and charts are being created, right? So these are some other things that we can do using GIS. So we can put more information on maps, right? We can put more information on maps. So information means things in the real world, layers. So the land use, streets, districts, parcels. So these things. Right. So and the most important thing is when you are dealing with GIS, geographic information systems, you have like we have this concept of layers, right? So one layer on top of the other layer we can use to build maps. So you will basically understand this when we are doing our practical sessions. So in our practical sessions, by using QGIS, you will understand this. So, but here basically keep in mind that the use of layers. So for example, here in this layer there is information about land usage. In this layer there is information about streets. This layer has information about districts, right? So things like that, water, things, rivers, like that, layer by layer we can add one on top of the other to make a map, right? So here, as I have mentioned, information is organized into layers, right? So rivers, lakes, states, roads, cities, so these are separate layers. So here in the middle you can see the collection of all those layers. So if you can see here, here are the layers. So the collection of these layers are combined all together and a map is created, right? So you will understand more about this when we are doing the practicals. So here also you can see the GIS world model. The GIS has modeled the world using different kinds of layers: imagery, elevation, transportation, addresses, things like that, right? So what else can GIS do? GIS can answer questions. GIS can answer questions, right? So what kind of questions can GIS answer? Things like this. You can see here this kind of questions. So normally what we do is like I have mentioned before, we can use the Google Map and we can use it to answer these kind of questions. What is the closest Pizza Hut? What was so where was the last earthquake? That actually we cannot answer using Google Maps, but there are some other sources and applications where you can get this kind of information. The population of people in United States. So these are some questions where you can ask based on geographic information systems. Right. So these are some other ways or some other fields where GIS can be used for energy forecasting, agricultural efficiency, carbon management. So these kind of fields use GIS in order to find answers to their related questions, right? Disaster management, things like that, right? So we can plan using GIS. We can plan. We can build cities. We can build do city and urban planning. We can build virtual cities, right? We can do effective usage of land, right? We can use GIS for those kind of applications as well. We can use GIS to manage the land, right? Integrated land management. Integrated land management, tax mapping, property evaluation. So those kind of things you can use using GIS. GIS can also be used to help public and safety and help law enforcement. So things like natural disasters or man-made disasters can those situations can get answers using GIS. So fire responses, things like that. And in law enforcement, crime analysis, how crimes are happened in certain areas, those kind of things can be analyzed and helped using GIS. So like man-made disasters, natural disasters are also there. So we can manage natural disasters using GIS related maps and stuff. Basic needs of people like electricity, water, phone. So these fields can also be managed using GIS. A better management, if the better management is there, total cities and countries will be created, right? So total cities and countries are planned and created with a better management. So fields like transportation, real-time traffic, these kind of information are also can also be managed using GIS. And in the nature related phenomena like earth science and water resources, hazards, floods, these situations can also get a help by the use of GIS. We can also monitor climate and energy, how the weather is being changed, how the climate is being changed short term, in a short term and long term manner, right? The climatical change, how the impact, how it is impacted, right? What are the impacts? So those kind of things also can be monitored. So here we use a large amount of data for data which is being recorded for a long time. We can protect our country as we can do criminal analysis, and we can use we can build models, and we can build security, geographical security So these are actually done by in a government basis. So global surveillance, it is also available in most countries, right? So you too can use GIS in the real world. You can find and collect field information, and you can upload those information by using certain applications. For example, by using Google Maps, you can upload the information that you have found, right? So, and that is a very important term when talking about GIS, the GPS, the Global Positioning System. So it locates where you actually are. So it is based on the several satellites which are orbited around the Earth. So by using these satellites and other other tracking systems, you can it is able to locate where you actually are up to the point on the Earth, right? So that is a global positioning system, or GPS. I think you know that term. So this is some in some example where this GPS is being used and how it is being shared throughout devices. So all of us can use GPS, you, me, and maybe researchers, anybody can use GPS. So how you can answer GIS related questions is, you can think about a topic or a place, you can ask a question about it, you can make maps, you can perform analysis, and based on that analysis and based on that information, you can ask a new question, right? So normally that is how we answer GIS related questions. The thing is, you have to ask questions, right? You have to ask questions about the Earth, anything that happens on the Earth, on and around the Earth, and you can make a map. So what you do is, you put the information in a spatial area, so that is called a map. So we will be talking about maps. Okay, we will be talking about maps in your applications. So GIS in our everyday life, we can use GIS for mapping, decision making, and we can plan the future, right? We can use GIS in any of these areas. We can do mapping, decision making, and we can plan our future. So yeah, so we will be talking about QGIS, and we will be starting our practical sessions from next week onwards. Yeah, we can start our practical sessions from next week onwards. I think your institute will provide the software QGIS. Did any of them mention about that? Yes, did your institute mention about like providing the software? Actually, QGIS is freely available. You can download and install it. You can install any version that you like. I will. I can give you a link to so that you can download the software and install it in your machine. So next week we will start doing our practical sessions using QGIS, right? So we will talk about QGIS from the next week onwards. So do be ready. Download QGIS and install it, and we will start on it from the next week. Okay, so if you want, you can, I think you can ask your institute, maybe you have a repository or something where you can download the application. You can like contact your course coordinator and you can ask about it, right? Okay, any questions? Any questions?
No, ma'am.
Okay, then do be ready with the QGIS application. And sorry, I couldn't send the lecture notes to your course coordinator. I will send it today, so he will upload it or send to you, right? And I will also send the activity, the exercises that we are starting to do from the next week onwards. That also I'll send it to you through your course coordinator. Okay. Okay, then we'll stop for today and we will start our practical sessions from the next week onwards. Okay, then until then, have a nice week.
Thank you very much.
Thank you, ma'am.